Okay, today I will present about Gauss elimination method. Okay, okay. We choose Gauss elimination method to solve our problem in the mathematical problem. So in our question, we got the matrices, which is 35, 0, negative 14, negative 14, negative 7, 21, 0, 20, and negative 7. So from that, we use elimination method. For step 1, we eliminate S1 from R3. So the formula we use is A31 over A11 R1 plus R3. So we insert the value of A31 is negative 14 over 35, 35 plus negative 14. And then we get the answer 0, 15.4, negative 7, and 0. So from that, we get the new matrices, which is 35, 0, 0, negative 14, negative 4, 15.4, 0, 20, and negative 7. So from that, you can see that we change the negative 14 to 0. And then we go to step 2. Step 2 is eliminate x2 from R3. So from that, you can see that there is 15.4. So we must exchange 15.4 to 0. So we use the formula negative A32 over A22 R2 plus R3. So we insert the value for A32 and A22. So from that we get the 15.4 over negative 7 minus 7 plus 15.4. So from that we got the answer 0, 37, and 0.11. And then this is the new matrices. We got the 35, 0, 0, negative 14, negative 7, 0, 0, 30, 0, 20, and 37. So from that you can see the 0 perform triangle in the matrices. So from that we can search for U2, U3, and U4. So for the value U2, U3, and U4, we get the value. So for the U2 we get 0.0005. For U3 we get 0.0014, and U4 we get the 0.0030. Okay, that's all from me. Thank you.
Assalamualaikum, my name is Mohammed Faizal bin Osman, AE20009, and I will explain to you the calculation using Gauss elimination method with pivoting. The matrices is 35, negative 14, 0, U2 equals 0, 401, 0, negative 7, 20, U3 for U3 equal 0.05 for row 2 and negative 14, 21 and negative 7 U4 equal to 0 for row 3. The first step I skip is because the 811 is already at maximum value, and the second step I skip because we don't eliminate because the value is already at 0. For the set 3, we eliminated x1 from R3 by using the formula negative open bracket A31 over A22 close bracket R1 plus R3 to row 3. And I do the manual calculation, and the matrices become 35, negative 14, 0, U2 equal to 0, 0, negative 7, 20, U3 equal to 0.05, and 0, 15.4, negative 7, U4 for equal to 0 for row 3. And step 4, I swap R2 and R3, and the matrices become 35, negative 14, 0, U2 equal to 0, 0, 15.4, negative 7, U3 equal to 0. 0, negative 7, 20, U4 equal to 0.05 for row 3. And step 5, I have eliminated the x2 from R3 by using the formula negative open bracket A32 over A22 close bracket R2 plus R3 to row 3. And I do the manual calculation and I got the matrices 35, negative 14, 0, U2 equal to 0, 0, 15.4, negative 7, U3 equal to 0, and 0, 0, 16, 81, 82, U4 equal to 0.05. By using the calculator with radian mode, I got the answer 0.0005 for U2, U3 equal to 0.0014, and for the U4 equal to 0.0030. Okay, and the answer is the same as the calculation using MATLAB. Okay, that's all for me. Thank you.
Hello, my name is Imam Hakim bin Zardin with the matrix number of AE20037, and I will be explaining to you about the simulation of our Gaussian method along with pivoting method. So right here I have the code, and right here we can enter in our matrix, and we can also enter in our answer matrix as A and B, and then we can put in the n as the length of b, so how long it is. So this is going to be a three-dimensional matrix, so the n should be 3. So the x, the zeros, n and 1, this one we'll see for later. And here we have the matrix of a and b to make sure we have the matrix of the forward, which is the matrix, and the answer for the matrix. And here we can check what that matrix is. Here we have the making of the zeros of the matrix, so we know that the matrix is all turned into zeros. And here we have the elimination method, the backtracking of the Gaussian method. It changes everything, and we can find the U2, U3, and U4. If we run the Gaussian method right now, you can see, enter your first matrix, and our first matrix, uh, I have it right here. If you press that, and then we enter the answer matrix, which is 0, 0.05, and 0, we get these. So here we can check it all. This is our matrix, as you can see from our proposal. And then you can see that we changed all from negative 14 to 0, from 21 to 0, and then this one's 37 and 0.011. And then from there we can also find the U2, so U2, U3, and U4. We have found the answer. For the pivoting method, let's clear everything. For the pivoting method, it's technically the same. The only difference is that we have this line of code. What this line of code does is it finds the maximum and the minimum. So this one is finding the maximum from the matrix, and this one is the declaration. So from A and B, it changes it to M and P, so we know we can use another variable in the code. So, and then this one and this one is just changing the code, changing the levels of the matrix. So from the lowest, the highest, it changes the position of it. And here under here, I added this one so that we can check whether we can find whether we can check if it's true or not that we changed the position. So if I run this one, we can enter our matrix again, this one and this one. you can see that this is our original matrix, and this is our answer right here on the left side. And we can see that for the M on this one is 35. That's the most highest one. And then P is supposedly the lowest one, but I'm not sure. It got 1 right there. But yeah, since that one's the highest one, we don't need to change anything. So we got 0 on that. And then we can change it from that under 1 to 0. So that's for the first row. For the second row, we found that 15 is the highest one. So we can change that with, oh wait, it's the rows. So the row is row 1. So that's why. And now it's row 2. So we'll change it to row 2 right here. As you can see, it's row 2. So 15.4 is changed to row 2. And as you can see, it changed. And that makes it to 0. And so, yeah, -7. So 15.4 and -7 becomes 15.4 -7 to row 2. And then we have 0 underneath, and we just repeat the same thing. And then from there we have everything, the tree and the triangle of zeros. We can find u2, u3, and u4. And that will be the same as the answer in the Gaussian method. That is for the simulation. Thank you very much. Yeah, thank you very much.